Good evening, ladies and gentlemen. Welcome to the last day of our webinar series organized by the GAP Research and Development Center in collaboration with India Sri Lanka Foundation. So we're thrilled to have you with us at this concluding session. So today's topic is Biomimicry in Agriculture, conducted by Dr. P.B. Dharmasena. We will explore how biomimicry principles can transform agricultural practices, leading to more sustainable, efficient farming methods. So it's great honor and pleasure for me to introduce our resource person for today, Dr. P.B. Dharmasena. Dr. P.B. Dharmasena is a visiting lecturer at the Rajata University of Sri Lanka, and he is a former deputy director of the Department of Agriculture. And also, he is a researcher with over 30 years of professional experience in soil and water management. The area covers various aspects such as small hydrology, soil erosion and conservation, watershed management, small-scale farming, indigenous knowledge, and etc. So he completed his PhD, MSc, and BSc from the University of Peradeniya, and he obtained a postgraduate diploma in soil science from the Agricultural University of Norway. And also his key research interests are in the areas of ecosystem, biodiversity, watershed management, tank cascade system, irrigation and water management, ecological agriculture, environmental management, and he has published over 80 papers in reviewed journals. Also, he is actively engaged as a consultant with FAO, UNDP, UNEP, IUCN, Plan Sri Lanka, ADB, WFP, WB, and several other organizations. So I cordially invite Dr. P.B. Dharmasena to share his valuable thoughts in this webinar. Dear sir, over to you.
Okay, thank you, Ms. Sadipa Dinali, for your kind words about me. And also, thank you for organizing this particular webinar series. And today we are going to have the last one, right? Yes, last one. I'll share my screen. Today we are talking about agriculture, biomimicry, and sustainable agriculture. Nature-inspired solution for a greener future. We talk about few things. One is just a brief introduction, and we try to compare natural ecosystems and our agro-ecosystems in Sri Lanka. And also we are trying to analyze the present situation of major agro-ecosystems in Sri Lanka, and also for transformation of agro-ecosystems with some recommendations. And we will discuss about our agro-ecosystems in Sri Lanka, major ecosystems, rice fields, then home gardens, rubber, coconut, and tea. At the same time, we try to introduce some concepts just to go in hand with nature-inspired solutions for these agro-ecosystems. Yes, I will start with some historical aspects of small agricultural societies in Sri Lanka. At the beginning, they were in the forest and they had some challenges and they found some strategies. So when they adopt these strategies, they could be able to come with some outcomes. We will see what will happen. Now we have divided here the preliminary agrarian society into three. One is foraging society. That includes hunting and gathering, all from forest. What they wanted is to water and protection. Finally, they have come up with beliefs and practices. That is the first part. Second part, we call pre-agrarian society. There they had the problem of wildlife, how to get the protection from wildlife, the natural disasters, then external invasion also, so that they developed some kind of strategies like farming. Earlier they did hunting and gathering. Now they learn from forest and they started farming, then rearing animals, tamed animals and rearing animals. Then they are a little bit civilized so that they could be able to share what they have. Finally, they have come up with disciplines, customs, and traditions. So that is the second. Third one is the agrarian society. Then they have the need for a leadership. And also they want to go here and there. And they want to transport some goods. So that they have developed some strategies like agriculture and some industries and trading. So that they have come up with culture, their own culture, and some kind of technologies, and finally, politics. So this is the way that we could be able to analyze what, from where they have come and how they did it. So from the forest, coming to the open forest, open lands, close to forest, then they have their independent areas for settlements. So that still they have adapted a lot of natural phenomena and they were with the nature. Biomimicry is a new thing for the world, but it has a long history. I don't want to go into detail. I will start with modern biomimicry because that is where we have to start our discussion today. Biomimicry, a new term, but it's for ancient wisdom. It's a long history that people have been there facing some challenges, developing strategies, and they try to imitate the natural models, systems, and elements to solve their multifaceted human issues. So the biomimicry came from Greek language. I think we have discussed those things earlier also. The concept of modern biomimicry was first introduced in 1982 by Dr. Janine Benyus. She has published a book published in 1997, Biomimicry, Innovation Inspired by Nature. So this is not only for agriculture, for a lot of other things like industries, construction, engineering. Now today, this is the 5th day and the last day, we are now talking about agriculture. Just I wanted to remind again and again, because as we are now dealing with agriculture, we are trying to relate that to ecosystems. Biomimicry is basically taking a design challenge and then finding ecosystems that's already solved the challenge and literally trying to emulate what you learn. So we learn from nature. We try to imitate that one for our needs. That is biomimicry. Natural ecosystems have been evolved to survive in many challenging landscapes. That's what we discuss. Over a million of years, they have tried, tested, then optimized. We call time-tested findings, strategies for surviving droughts, floods, and famine disasters, and also epidemics. So where are these people who had the kind of knowledge and skills? They found strategies for surviving those things. So innovative farmers learning from native ecosystems to design resilient landscape, which clean rivers, reverse climate change, and provide more stable food production. Just to illustrate this one, I will take one example, mangrove ecosystem. Mangrove ecosystem, it has kind of special adaptations to take in extra oxygen and to remove salt and absorb some kind of nutrients which allow them to tolerate conditions that would kill most plants due to salt water. So they learn from this mangrove ecosystem and develop some kind of strategies and technologies by studying natural ecosystem. Now they are okay with improved saltwater farming. That is the way that we can adapt mimicry, biomimicry. What is biomimicry in agriculture? The imitation of natural models, systems, and elements to solve issues in agriculture. Transform present agricultural production models, production systems to agro-ecosystem models. That's what we are discussing today. Learn from natural ecosystem models, the behavior and functions of the systems to develop agro-ecosystem models. For example, now very well-known example, this lotus effect. Hydrophobicity of the lotus leaf for storage and transportation of fruits and vegetables. We know that once we produce a lot of fruits and vegetables, our problem is how to transport, how to store it, so that they have taken cognizance from teachings of nature like lotus leaf. Our agricultural ecosystems in Sri Lanka, we call agro-ecosystems because even though some people think about agricultural production systems, there are differences. We will take major agro-ecosystems. One is rice paddies, rice fields, then plantation crops, especially tea, rubber, and coconut. Those are the major crops. Then field crops, seasonal crops, and home gardens. So we will take all these six agro-ecosystems and discuss about the possibility of transforming the production systems to agro-ecosystems. These are the selected agro-ecosystems: rice, field crops, home gardens, tea plantation, rubber plantation, and coconut plantation. Even though we think that coconut and rubber, they are monocrops. If you look at this rubber plantation photograph, you will see a lot of weeds. That means wheat can grow there. Why these plants, crops cannot be grown there? So that we have to transform this onto agro-ecosystems. What are the teachings of the natural ecosystems? Some characteristics of the natural ecosystems we are using here. Once we use this, then it will become agro-ecosystems. One is we'll have to have mixture of species. So it is not monocrop cultivation, it is mixed crop cultivation, then biodiversity is rich. Then canopy stratification, that means the competition for light is minimum. Root depth variation will give us the opportunity to have different moisture regimes and also nutrient regimes. And the way that the root depth is distributed among this competitive environment. Then microclimate creation. In some places now, for example, here the photograph shows oak tree, and it will create a microclimate here for other plants to grow. Then because of this more and more diverse biodiversity is there, so that we can expect soil fertility enhancement and improved soil microbial activities. And also with time, these systems adapt resilience to natural disasters. Finally, most important one is if we can enhance the carbon sequestration, that is what we need even for climate change strategies like greenhouse gas emission reduction and also improved carbon sequestration from agro-ecosystems. Here we have a situation analysis taking the previous biomimicry factors, and we try to analyze major crops: rice, field crops, home gardens, tea, rubber, and coconut. So that you can see here, in some places like home gardens, if you look at that one, very high level of biomimicry. Home garden, biodiversity high, canopy stratification is high, root depth variation is high, microclimate creation is high, natural soil fertility enhancement, improved soil microbial activity. So that you can see that is very close to nature. But still, there are something to improve, like resilience to natural disasters and enhance carbon sequestration. Enhanced carbon sequestration means it has carbon sequestration, but we have to improve. Then if you take tea is a very monocrop cultivation. It is not much levels of biomimicry. For example, species mixing is very low, canopy stratification is low, root depth variation, microclimate creation, all are low. So we'll have to do we have to adapt a lot of strategies to improve this one, to transform from production systems to agro-ecosystems. Rubber and coconut will have to see that if we can introduce to increase biodiversity, if we can introduce intercropping, that's a very good strategy. If we can introduce intercropping, that means it will start having all these factors positive, like biodiversity, canopy stratification, root depth variation, microclimate even, and soil fertility enhancement, and so on, so forth. Now we know natural ecosystem is having some characters. When it comes to agro-ecosystems, what will be the difference? So that to minimize the difference, we'll have to make some recommendations. That is what we are trying to do. One is solar energy only, no additional energy input in natural ecosystems. When you come to agro-ecosystems, we use solar energy and also energy from food. That means labor we are using and fossil fuels, machinery and transport. For that, we need some diverse diverse energy sources. What we recommend is the green energy. Green energy is the energy that can be produced using a method and from a source that causes no harm to the environment, natural environment, so that it is harmless, it is sustainable, and it is safe to use, so that we are trying to discourage use of fossil fuels as an energy source. Second one, lower productivity in natural ecosystems. What is this productivity is? What is coming out of this for human use, especially? So what we did, even if you can remember in era of Green Revolution, starting in 1960s, we go for high productivity, high yield, high income. So we had to use chemical fertilizer, then chemical pesticides, and sometimes varieties, different varieties, and we use machineries, so that we got higher productivity. But it is not sustainable. Now we realize, because of that, we recommend sustainable and optimum productivity. There are a lot of criticisms on this, how we can achieve sustainable and optimum productivity to feed the nation, to feed the world. But you know that when we do it, what we have come out with is soil pollution, water pollution, air pollution, health problems. So that argument is, with all these, do we need to achieve high productivity? That is why I say optimum productivity. Then species diversity. Agro-ecosystems, at present, we have less species diversity. If you take paddy, if you take rice, if you take rubber, tea, coconut. To compensate this one, what we recommend is one concept, boundary green avenue concept. We will discuss that later. To increase diversity, introducing more species. Then more genetic diversity within a species, you can find it in natural ecosystems. When you come to agro-ecosystems, less genetic diversity within a species. So what we suggest is that introduce varieties adaptable to natural stresses, water shortage, excess moisture, pest and high winds. For example, if you take paddy varieties in Sri Lanka, we have land races of about 2,440. Can you imagine such a vast variation, wide variation of these these varieties. Now, why we wanted to have this so many varieties? So that varieties will stand for drought, some varieties, excess moisture, wind effect, and also the produce is rice for different health problems. They had this over Sri Lanka, land races of about 2,442. That is where we get this biomimicry. Then natural ecosystems, nutrients are recycled naturally within the ecosystem with little addition from outside. This natural recycling is more limited than supplemented by the addition of artificial fertilizers. That is what we have adapted from the time that we have introduced Green Revolution. What we suggest that add more organic matter sources in Evergreen agro-ecosystems concept. So that concept also we are going to discuss later. Then the other one is population. Pest populations are controlled by natural means such as competition and climate. If you have more diverse environment with plants, that particular environment will act as habitat for predators, and pest predator ratio will go up, and that will be controlled naturally. In agro-ecosystems now, populations are controlled by both natural means and by use of pesticides and cultivation. So what we recommend that forget about the chemical pesticides, we have biopesticides and try to adapt the ecological environment for their farming. Now we know that we have come up with a lot of agroecological zones with different climatic features so that we know where we have to grow what. Then the climax vegetation. In natural ecosystems, it can be reached very easily, natural climax community. Generally, because we are using agroecosystems, pruning, lopping, harvesting, so that it is very difficult to achieve climax vegetation in home gardens, especially. But if we can adapt agroforestry systems, agroforestry approach, then really you can try your best to achieve some kind of climax vegetation, not always. So we are trying to think about agroecosystems separately. Now, for example, rice field agroecosystems, where you get different types of rice fields in Sri Lanka. One is irrigated environment, under maize irrigation, Mahavali schemes, and also minor schemes. So that this is the most popular one in Sri Lanka. Then rain-fed lowland. Lowland is here the wetlands. So this is dependent on the duration of rainfall, and hence with an uncontrolled shallow water depth ranging from 1 to 50 centimeters. So that once the climate change comes in, this is something, a challenge. Then deep water environment, again I want to repeat the same thing, that we have many varieties, rice varieties, which are adaptable to different environments like deep water, rain-fed uplands, and tidal wetlands. Unfortunately, now we are not using all these traditional varieties, except some improved varieties targeting for high yield. That is where the sustainability cannot be ensured. Rice field agro-ecosystem, it's an ecosystem which will provide 4 different services, like what we know that there are 4 different services. One is regulating services, then provisioning services, then supporting services, and cultural services. So that we will take one by one for rice agro-ecosystem. One is regulating services. So we can regulate, we can control soil erosion, we can reduce the impact of drought through water retention and groundwater replenishment. Then we can regulate runoff by using proper drainage systems. Then we can reduce the effect of driving. So some biobarriers like live fence and green hedges. And also you can remember that I have spelled out one concept that also will do a lot of things. Regulating flood through rainwater absorption and excess water drainage. So that regulating services are okay with rice field agro-ecosystems. Provisioning services. It can provide nutritional and healthy food by growing medicinal rice. And also it provides green manure from live fence and green hedges. The most important again, that if you have some kind of habitats, especially for predators, it can be utilized to control pests. Then supporting services. Support to human health, nutrients, medicine, moist and shady and pollution-free environment so that people can live there in that favorable environment. Then it can enhance soil microorganisms populations so that the soil will become so fertile and it will be good for the crop. Support to assure a steady income from increased cropping intensity and crop diversification. These are something we learned from our research programs. Then cultural services. What kind of cultural services that we can expect? Especially in the dry zone of Sri Lanka, sometime during dry period, you can't see any kind of aesthetic beauty of the surrounding. If you go to dry tank pit, you will see flowers, right? So aesthetic beauty of the surrounding is very important. And also social cohesion and happiness by working together. These people in rural villages, they used to do always as a teamwork, right? If they go to forest, they will go as a team. If they wanted to harvest something from the forest, they will go together. If they want to practice shifting cultivation, they will share lands and work together. If you see that the paddy cultivation is they commence with all these in time according to the decision that they are making at a meeting. And also, when they do that, they don't have any competition with neighbors. So that they will share it. They will leave all these other attachments. They are doing everything peacefully. Then also, when somebody is required to learn something from this particular ecosystems, they can come and get the education from this practical field. And also, if this is improved ecosystem, it can be utilized for ecotourism too. And they have their traditional rituals. They do it before cultivation and also after cultivation. So that they strongly believe that these unseen powers will support them and support the crop. So as we earlier discussed, evergreen agroecosystems concept. Why we wanted to have it? Because in seasonal crop cultivation, there are fallow periods where you don't get any kind of greenery. So that it will not contribute to carbon sequestration. At the same time, it will not support the increased oxygen level. So that we need to see the whole field with greenery effect all over the year, so that we can use one crop, short age crop, and long age crop, or one crop we can cultivate after when it is ready for harvesting, we can use another crop. For example, now we know that mid-season cultivation, just after harvesting the rice crop in March season, people use the same land without any kind of land preparation for mung bean, green gram. And also, we try our best to see that the zero fallow period of the land, cultivation with different crops. Farming models which combine seasonal, semi-perennial, and perennial crops ensuring the green cover around the year. Now we know that in some places, through some projects, development projects, we try to introduce perennial crops in rice fields. Rice fields where you don't get a good harvest, good growth because of some other problems like nutrients or maybe soil moisture. Then also we can introduce green manure plants such as Glycidia CPM, Ardatoda vesica, Erythrina, Hespecia, etc. We can grow them as hedges. So that is we call evergreen agroecosystem. So we can minimize light competition to maintain cropland with evergreen situation because of the shade management and stratification of the vegetation that we try to introduce in addition to the main crop. Then live fence is maintained with plants to create stratification, enabling to act as wind barrier as well as favorable microclimate in the crop field. This is we call later we are coming to discuss about that green hedges. Benefits of evergreen agroecosystems. One is we can expect year-round soil cover protection, and also it will control soil erosion, and also it will increase soil organic matter in the soil. Improved plant nutrition via new nitrogen fixation, nutrient recycling because we are using legume trees. Ecological sound control of insect pests and weeds because of these introduced green hedges that will act as habitat for predators too. Enhance soil structure and soil water recharge. Increase food production. Increase production of non-food products such as oil, fodder, fuel, and medicines. Increase landscape carbon sequestration. We will discuss about the carbon sequestration, how we can increase in home gardens. Conservation and enhancement of biodiversity. So in agroecosystems, what we expect, one is the conservation of resources, and enhancement of biodiversity. So, field crop agroecosystems and rice field agroecosystems, we can introduce evergreen agroecosystem concept. There what we do, we want to increase crop diversity from one crop to several other species. So we, for example, now if you look at here on these bunded fields, along the bund, we can plant 3 different species which are really tested at research station, in a dry zone research station. Now here you can see the example. Gliricidia will supply nitrogen and it will be planted on the bund 1 meter distance apart. Then within that about 3 Adathoda plants can be become bushes. It will supply nitrogen as well as phosphorus. Then citronella, that is Cymbopogon nadus, will supply potassium. It's a grass. And so that if you go through this, again, the same list, fish biodiversity, canopy stratification, root depth variation, microclimate creation, natural fertility enhancement, soil microbial activities, then resilience to natural disasters, enhance carbon sequestration. So all these characters can be found in these evergreen agroecosystems I have given here only as an example. You see the nutrient composition of these manure plants. Now we selected here Gliricidia, nitrogen 4.6. Then citronella, 0.77 nitrogen and 0.4 phosphorus. Adathoda, we use 5.04 nitrogen, 0.13, just, yes, 0.13% of phosphorus, that is just lower than only erythrina. But the problem is, we tried erythrina to plant within the field. It is not successful because farmers are reluctant to grow erythrina within the field. So that we have this nutrient compression for manure plants here. And the last one here, the other concept is that boundary green avenue concept. You know that we have live fence. Live fence can be broad, put some stratified species, large canopy, then medium canopy, then low canopy, ground layer, and also we can use some creepers here, then ground cover and roots and tubers. So it's a very diverse environment so that it will enhance the diversity, enhance the soil fertility, and also it will act as a habitat for a lot of other animals and predators. Now, if you take the examples, large canopy, you can use these 3 species, whatever the species that is available in your area, in your country, you can use them. Only thing, large canopy, medium canopy, low canopy, and ground layer. So there are examples for Sri Lanka, but you can find some alternative other crops in other countries. So here, boundary green avenue concept, again the characteristics that Diversity of crops. You can see here this green avenue concept, and it has the forest effect. Multi-layer architecture, shade management is very important for a crop, short crop. The nutrient recycling, it can share moisture and also microclimate, and it will act as habitat for a lot of other friendly and predators. Pest control can be done. Livestock integration is there. And finally, it will add aesthetic beauty. We can intensify home gardens. Now, natural ecosystems and our ecosystems in home gardens, we can see that mixture of species, it is increased biodiversity. Canopy, identification, fill in gaps with species of different canopy cover. Root depth variation, fill in gaps with species of root depths. Microclimate creation, yes. Soil fertility enhancement. Soil fertility is enhanced by adding prune and lopped plant debris, so that we can increase everything, the characteristics for natural ecosystem, to reach natural ecosystems in the home garden, so that carbon sequestration also can be increased remarkably, because we have done a small exercise here for this one proposal we have developed to see the roadmap and the strategic plan up to 2050, so that home gardens can be improved. Their carbon sequestration in million metric tons like this, taking wet zone home gardens, dry zone home gardens, and intermediate home gardens, so that there is a possibility, there's a potential for increasing, intensifying the home gardens. We found that carbon stock can be increased by 267% by the year 2050 through home garden intensification. And also you can see the other agro-ecosystems. For example, tea, we have to do physical repair in stone bunds, lock and spill drains, that is specific to Sri Lanka, salt, leader drain, and gully conservation measures. Then we can improve the vegetation by infilling and replanting of tea. Then intercropping, that is everywhere. If we do intercropping, it will increase biodiversity, especially. Weeding, manual weeding, loppings of green manure crops and grasses, soft weeds and mulch. When you introduce agro-ecosystem, then you are going to introduce trees, shade trees, so that the shade management will be there. The live fence, wood forest garden concept, green hedge, the green hedge with grass species, mulch cover, grass and legumes, composting with crop residues, use of cover crops and green manure for erosion control, water supply during dry periods. There are some areas like Ua province in Sri Lanka. Then we have to construct rainwater harvesting ponds and micro irrigation systems there, not for all these tea lands. Then crop diversification in underutilized or abandoned crop lands into tea plantations, so that we can use mixture of mixing with other crops. Then here we can do intercropping. This is for rubber-based ecosystems. Structural bunds for conservation of soil. vegetative green hedges and cover crops, perennial canopy plants, fruit plants can be there just as a row. Then agronomic practices we can use vegetables and incorporation of green and organic matter. Then boundary green avenue concept where you can have Gliricidia, then Cassia siamia, Adathoda vesica, Sespenia grandiflora, Helianthus amnus and lablab. Then sechim is a vegetable. So that we have different species available for intercropping and also for agroecosystems of different crops like tea, rubber, and coconut. This is for rubber-based agroecosystems. Here also we have biofertilizer, biopesticide, intercropping tea with rubber also. It's possible. Microbial and natural pesticides. Pest repellent, especially. There are pest repellent species we have selected like this. Cymbopogon citratus, Cymbopogon nardus, then turmeric, ginger, arath, because of the strong smell, it can repel pests. So that we can plant these special species within the farm so that you can minimize the pest attacks. Then coconut agroecosystems, you can again integrated nutrient management and also intercropping is very important. Here you can see that pineapple and here coconut, then here coconut and cocoa, so that you will find different combinations of these intercropping. Then green manuring, soil and water conservation measures, weed management, irrigation, fertigation, cropping, farming system approach we can adapt. So that there are possibilities, there are opportunities for us to transform this tea or rubber or coconut or rice or a home garden into agroecosystems. This is again intercropped banana, coconut with turmeric. Finally, what we have discussed so far is that the agroecosystems, rice field, field crops, home garden, tea plantation, rubber plantation, coconut plantation, with some concepts, so that it is very easy for us to convert these production systems to agroecosystems. That is why we say that learn from nature to make agriculture a sustainable venture. And it will provide productive and successful systems for farmers to earn more and more money. So that's the end of my presentation. I think I have taken almost 55 minutes. So thank you very much. Over to Sadeepa for question and answers. I'm waiting. Thank you.
Thank you very much, sir, for your insightful lecture. So now you can answer the question from this to the webinar.
Good evening, sir.
Yes.
Sir, this side Rajan, sir.
Okay.
And it was lovely to have a very good insight of things in terms of agriculture, how we can do this, that. Being a RD scholar in tourism, what I would like to suggest is if we can look into, say, agri-tourism,
Agro-tourism, yes.
would be yes, sir. So that would because in the entire session, couple of sessions that we have attended, what has
I think,
happened is we've been talking about biomimicry and engineering models and agricultural model that we spoke about today. If we can, club it together, agri-tourism could be the next zing thing.
yes, what I believe that agro-ecosystem cannot be done just with one plantation or one farmland. So we have systems. For example, you may be familiar in southern India that you have some tank systems, right? There you
Yes,
get,
sir.
you have, right?
Yes,
Yes.
sir.
Yeah. Here also we have minor tank agro-ecosystems. Minor tank agro-ecosystems. There you get lot of things can be learned and lot of aesthetic beauties can be developed, and people will be attracted because now we know that there are places where we have tried our best to get some kind of agro-eco tourism. For example, now you know that we have agriculturally important global systems, heritage systems, right? So, yes, agriculturally important global heritage systems. We have only one here, that is minor tank ecosystems, 39th of the world. And you might be familiar with this in India. There are a lot of that kind of globally important agriculture heritage systems, right? So that will attract tourists. So those are agro-ecosystems. Are you happy with that?
Sir, perfectly, sir. Sir, also, I would like to request you to kindly share the presentation that you have done. I've taken plenty of screenshots, but then that won't be very clear. If we could get this, we can try and club or fuse tourism with agriculture and biomimicking. That would be one
Miss
aspect that we are looking
Miss Sadipa,
to.
are
Yes,
you
sir.
there?
Yeah,
Miss Sadipa, now I have given few links to you, I think, through email.
yeah.
So you can share with our participants in the virtual audience.
Yeah,
And
sure, sir. I will share it.
yes, and also this particular presentation. Okay.
So along with the other presentations that we have attended for
Yeah,
last
that
couple
is
of
what I
days.
say. Yeah, that is what I say that I think you can
Yeah.
share all these presentations within these 5 days. Can you?
Yes, sir.
Okay.
We will share the recordings and all the presentations within.
Right. Great.
Right, sir. Thank you very much, sir.
Welcome.
Right. Thank you very much, Dr. Dhamsen, for the interesting presentation. I'm Professor Veer Singh here. Just I have a small query regarding this agro-ecosystems approach and the biomimics. Whether biomimics to be incorporated into the agro-ecosystems, or we have to take back biomimics from agro-ecosystems to put into other areas, other spheres. So, what do you think about that? How this approach can be extended from the ecosystem approach towards the biomimics and into the other spheres? Thank you.
Yeah. Thank you, Professor. What I suggest that now we have already interact with agro-ecosystems.
Yes.
And also mimicry is the approach. The way that is strengthen our way to agro-ecosystems. Not that we are following like a religion, the mimicry, but mimicry says some kind of recommendations for that. And even without philosophy of mimicry, it is same. It is the same. So that is why I say that natural ecosystems can be transformed to agro-ecosystems with these lines, so that mimicry will support the philosophy. There's nothing different. Okay. Professor Veer Singh, are you happy with that? Or we'll have to have more discussion? I don't know whether today we can have all.
So that means it is more philosophical approach or the technological approach to
No,
be
it has, yeah, it has come as a philosophical approach early.
Yeah.
Now it's on the ground. So the purpose of this particular webinar is to make some kind of implementable approaches on the ground, so that there may be implications. Of course, we believe that, but we can try. As I started my presentation, I told that this is nothing different. Mimicry, biomimicry is the same as the people are learning from nature and trying to adapt that imitate people and try to come up with some strategies. That is what I have shown from the first slide. Okay.
Yes, thank you very much. Thank you.
Thank you, Professor.
Good evening, sir.
Okay, good evening.
Yeah, may I ask a question? Right, I am interested in health and the communicable diseases. So,
Okay.
leptospirosis is increasing recently, and with the rodent population increase in the paddy cultivation and environment, is there any way that the agro-ecosystems has anything that we can use to reduce the rodent population in the cultivation field so that it can be implemented widely and reduce the disease?
Yes, rodent population, why it is increasing? Because their food chain has been broken somewhere. Do you agree? Now, you take the all examples, bats, what happened, bats, and what happened to rats, and then rat snake. So there's a chain. There's a, you know, that food chain, right?
Yes, sir.
When we try to do some kind of activity which will break the food chain, the one will increase, right?
Yes.
So that is what happened to. Then now we are getting a lot of other diseases like that dengue.
Yes.
And what is called that rat fever?
Leptospirosis.
Right.
Yeah.
I am not familiar with that.
Yes.
Anyway, that is the reason. Now we are losing a lot of species now. You know that.
Yes, sir. Yeah.
Because of the same point. So that our agro-ecosystems are there to take care of that kind of food chains. Food chains are there to get the environment sustainable with the support of these food chains. That is the way that I believe.
Yeah, of course, sir. Yeah. Thank you, sir. Yes.
Okay, thank you.
Sir, I have one thought going on since long, and I am trying to implement that with my center. I am working with the Center for Promotion of Ecological Adventure, Health and Cultural Tourism.
Mhm.
So, if we do club these biomimicry, what's the purpose of the biomimicry? Like the topic is biomimicry in agriculture. The end goal is sustainability. Like if we club the hospitality tourism sector with the agri-tourism, it's a full topic for the discussion and debate, and hope you will like it. Like we have the hospitality industry, so we are building big hotel, 5 star, then huge construction, lots of pressure on the environment. If we club the tourism with the like we used to do homestay or something like that, but if we club it with the agri-tourism, that's gonna be win-win situation for the sustainability as well as the less pressure of environment and there will be no AC, which are the biggest reason for the carbon emission and the pressure on the environment. Like we are reaching already in India 51 degrees Celsius, 47, 48 degrees Celsius. So
Yes.
agri-tourism can be clubbed, and I am keen if there are somebody who can club with us. We are Central University of Himachal Pradesh, located in Dharamshala. So it can be the new way to contribute, big way for the objective goal and the SDG 2030, the key goal of the sustainabilities. Because the more we will empower the farmer community, the more we are going to contribute for the environment protection and the conservation.
Yes, that's very important and essential. I think this green, the Miss Sadipa, now your organization can couple with this one.
Yes, so we can discuss with this.
We can
with our
discuss
team.
in detail. Yes. Thank
Yes,
you
sir.
very much. Thank you.
Thank you, sir. I will be in touch.
Thank you.
Right, sir. Thank you.
How is Miss Sadipa now? Are we going to wind up?
Yeah, sure, sir.
Sandeepa
Oh,
ma'am,
please
we
share
are
the
waiting
link for the
attendance sheet.
attendance.
So thank you very much, yes, sir, for your inviting lecture, and we greatly appreciate you taking the time out of your busy schedule to share your expertise with us. And we also extend our heartfelt thanks to all our participants for joining us throughout this webinar series. Your engagement has made this session truly valuable. So thank you once again. And also, we are excited to announce that we will host in a International Biomimicry Conference on the 20th of August. So you can see your abstract under these themes, and we will share more details with you very soon. So we
Please,
hope to see
through
you.
email.
Yeah, sure.
Yeah.
We hope to see you there as we continue to explore the incredible potential of nature-inspired solutions. So as we conclude this series, we hope the insights and knowledge shared will inspire you to incorporate biomimicry into your work and daily lives, and driving us all toward a more sustainable future. And we will share our recordings with you soon. So stay tuned for more programs and updates. And thank you once again. And we look forward to see you at our biomimicry conference. Thank you all, and good night.
Good night.